Hello. So now, let's quickly continue from where we stopped. Now, listen. The other aspect we want to look at now is uh, the simple pendulum. But this particular aspect requires a practical demonstration for everybody to understand what is actually going on. Now, when a simple pendulum, okay, I'm going to show you an illustration from here. I believe everybody can see. This particular aspect requires, please, can you see? Please, can you see the diagram? I believe everybody can see the diagram from there. So if you have your material here, I just want to show you the practical aspects. Then I'm going to explain in detail. I want everybody to please pay attention. This is a simple pendulum. A simple pendulum. Now this is a simple pendulum bulb. Okay? Now I want to show you the moving parts of that. Sorry, please help me hold that thing. Now look at this. Look at this. This is the bulb. Hello, please hold on. I want everybody to please listen to this aspect. I'm not saying that you don't know it, but just see what is actually going on. Now look at the bulb. If we display this bulb slightly, there is something we are going to observe. We observe that if this bulb moves, hello, please. If you display, you know, all you need to do is just to hold this bulb like a bit here. I get to that now. When you hold the bulb a bit here, you are going to discover that immediately you release it, it will start moving. When it moves, it will follow a path called parabola. Hello, listen to me. Hello, so please, if you cannot hear me from the back, please move closer. I believe you can hear what I'm saying. This is just a time opportunity to understand some things. Trust me, anything I tell you is the facts. I'm not bragging. That's why I'm using this textbook to tell you. For you to understand what is actually going on, so that you can know this thing forever. I get to that now. Look at this bulb here. This bulb must obey the law of conservation of energy. How? Look at this. When you hold this bulb now, you just display this bulb slightly like this, just slightly. You don't need to push it hard. Just hold it like this and push it slightly. Now, but the bulb will move. Are you getting that now? It will move and follow a path called parabola. But while the bulb is moving, along this path, moving through here, that's parabola, something will happen. And what's that thing? We are going to discover that between these points here, just directly proportional to the thread, to the length of the thread. I get to that now. The height of the object, we do what? It will appear as if it is reducing. Because the height is going to reduce at this point here. I get to that now. It will now stop and therefore start moving again like this. I get to that now. Then later, it will be coming back to the center. True of us. It will return back to the center. True of us. Now, let's see the analysis behind what I've just shown you. Take. Let me show you the analysis behind what I've just shown you now. Everyone, just look at the board, please. I'm begging in the name of God. Look at the board and see exactly what is actually going on. See. I believe you understand. Now I am in the lab now. Do you understand? I take a thread. This is my clamp. My tight top. Then I now take a small thread. I need a very small thread. I don't need a longer thread. I get that now. A very small thread. Then I now tie the thread to my pendulum bulb. I don't care about the ground. Then when I tie it to my pendulum bulb, Then I hold it. I believe you can see this. Then I now displace the bulb slightly. I get to that now. When I display the bulb slightly, I am begging the name of God to listen to this. Hello. When I display the bulb just slightly, now this bulb will be moving as if it is going against the law of gravity. I get that now. It will move like this. See, everybody see what will happen. It will move like this. Can you see? In the sense that, let's say this is the imaginary movement. Can you see? Like an imaginary movement from this point to this point. Now, it will now follow a path that appears parabola. I get to that now. Now, when it moves from this particular point to this point, I get to that now. Yes, sir. Remember, it will never come back to this middle immediately. I get to that now. It will move back again. It will move toward this junction again. Imaginary. And follow the same path again. Somebody get what I'm saying? Yes, sir. Now, why the bulb is moving from point A to this point here, the only thing we observe is that between these 2 points here, that we can measure the height which this bulb, do you understand, covers from this point to this point. Are we getting that now? And at this point here, the kinetic energy which the object is going to have will become 0. Yes. I get that now. It will become what? 0. And at that point, the potential energy become what? Maximum. Hello. The question is, why will the potential energy become maximum? Listen to the reason. Listen to the reason. Under gravitational field, we discuss about what we call gravitational potential. Gravitational potential here deals with this. When you are taking an object, hello, let's say if this is from a particular height to the ground. Every object that is dropped is having an effect of the force of gravity acting upon it. And that is why it is coming down. And the more the object tends to reach the ground, the more the height reduces. Somebody gets what I'm saying? Now, for these reasons, the height reduces as the what? As the object tends to drop. I get to that now. When the object reaches the ground, I get to that now. The object must have covered a particular height, h, not a distance. And therefore, it has a weight W, which is what? Mass times what? Gravity. The product of the weight and the height is the potential. Yes, the product of the weight and the height is the potential energy. So the product of the weight of this bulb and the height which it has covered is the potential energy. That's why it is maximum here. Don't say they didn't help you. Don't say I did not explain. The product of the weight of the bulb and the height h here, following the parabola, becomes maximum here. Why the kinetic energy, the energy which it has while in motion, is 0. Because it's at rest here. Are you getting that now? But listen to this. Hello, listen to this. Now, when you get to this point, the kinetic energy can never be maximum. It is 0. The potential energy is also maximum there. But listen, as the object tends to return back, the acceleration happens to be like this. When it is returning back to the center, the acceleration, it decelerates. And therefore, we are going to have this multiplied by this, where this is the parts which it has covered. It is the distance. X is the distance. So for every object performing simple harmonic motion undergoing simple pendulum, when the object is returning back to the center, the acceleration becomes negative to show that the object returned back to the center. Don't say it is correct. I am correct. You don't need to tell me. I know that I'm correct. Are you getting what I'm saying? Is it clear to you? Now, here, the kinetic energy becomes what? The potential energy becomes what? Simple analysis. This is the length of the pendulum. So for that reason, for me to know the period, all I need to do is for me to say that what brought about this relationship, my T is equal to 2 of these days. Are you getting that now? For me to know my period has to be the what? The division of my length and gravity. The question is why? I disagree. Agree or disagree? Agree. Agree or disagree? Now everybody see what I want to show you. See what I want to show you. What is speed? This is distance over what? Time. That's distance over time. Let's use our L to represent our time T. Hello. Let's use our L to represent our time what? Our time T. Class, well, let's go back to this. What is frequency? Frequency is referred to as what? The number of what? Times what? The number of what? The number of what? Where everybody see. Look at the board, everybody. Let's say this is our velocity, Abi. Yes, sir. Is that also? Look at this. I'm going to show you the simple relationship now. L divided by time is 2 pi. All together, multiply by 2 pi over g. Now, do you know what this means? No. This 2 pi over g. Do you know what it means? What it means is that you are telling us that for every of that circle that is covered, I get as it is moving along the circular path or undergoing simple harmonic motion. I get to that now. It is you are dividing it by what? By each portion of the force of gravity that is acting upon the objects. That's what I'm trying to tell you. So, yes, you are dividing by the what? This is one circle. One circle is like when you are saying that the gravity, the number of times, do you understand? In a circle, I get to that now, of the force of gravity pulling the object down. Because when you are displacing the object, it is moving to and fro. I get to that now, and there is a force of gravity that is what? That is acting upon the object. Look at it, this is the weight. Can you see? There is a weight W here, which is what? Mass, that is gravity, which is assumed to be proportional to the length of the what? Of the pendulum. I get to that now. So now, which is the number of what? Of circle it is covering. So now this number of circle divided by this, you understand? We still give you the same thing like time. This number of lengths divided by this, we still give you the same thing as time. So relating the two time together, you cancel this, you cancel this. So now which means that, which means that naturally my period is directly proportional to the square root of what? This. Sorry, this. My period is inversely proportional to the square of what? Are you getting that now? Relating the two of them together. When you relate them together, that means during when an object is undergoing simple harmonic motion, which is simple pendulum, the length, the square of the length is directly proportional to the period. The square of the period here is inversely proportional to the square of the force of gravity. That's what it means. Are you getting that now? So now therefore, period T is equal 1 cycle to the root of what? Length over what? G. You can write this down. Write it down. Write it down. This is simple pendulum. You draw this. Hello. You write the formula. This is the formula of this is the period of an object performing simple pendulum, simple harmonic motion. That's a simple pendulum performing simple harmonic motion. This is the formula. Period is equal to this root L over what over G. Is that okay? You draw this diagram. This guy is 0 here. Kinetic energy, this is maximum here. This is what? Maximum here. Potential energy is 0. This the same thing as this. I get that I'm following a parabolic path. Do you understand? To cover a particular what height from this junction. That's all. And from here, you can easily what? You can easily calculate the angle. I get that you can calculate the what? Now for A level. Hello. For A level. The reason we are reducing this is because this one is still within secondary school. Hello, it is still within secondary school. I get that now. It's still within what? Secondary school. When we get to the advanced level, there are some things we are supposed to do here, of which we have to omit now. Yes. Now let's continue. Do you have this? Remember, don't forget that this negative sign means that the object is always coming to the what? The acceleration of the object is always toward the what? Center. That's what it means. Don't forget this symbol here. Is that taken? Don't forget. God will help you. Well, let's interpret this. Let's take a particular problem from here. Let's take problem from here. I'm waiting for you, please. Okay. Now, can I rub the board off? No, let's be fast, please. The streaming is over. The streaming is over. You can see. Hello. Tell him the streaming is over. So, can I rub this off?
Yes, sir.
Where is the network?
Okay.
Hello.
Why is he stopping? Can you stop? Hello, Beku there.
Okay. So now let me quickly.
Hello, we are making it.
Hello. So are we ready? Are we ready? Okay. So please let us take this time. We have just few minutes for us to end the lecture. So now, before we end the lecture, let us quickly take this relationship. Now, everybody, look at the board. Hello, can I rub this off?
No.
Can I rub it off? All right, no time. Class, let us take a relationship to relate this. Now, class, let's see. Class, look at the board, please. But T is equal to this guy root this guy over this. Hello, please hold on. Now, let us square both sides. Let us do what?
Square both sides.
Let's square both sides. Let's say this guy will be T square 1 Do you understand? Yes, there is something I want to do. Let's say this guy is t square 1. This guy is going to be 2 pi, open your bracket, square. I just want to do it like that. Then I want to square this L1 over what G. I'm squaring both sides. Hello, I want to square both sides. There is something I want to derive. Are we together? Now, t square 1 is equal 4 pi square multiplied by L1 over G. Now see, class, see what I want to show you. But t square 1 is equal 4 pi square over G multiplied by L1. Now let's assume that this guy is constant. Hello, let's assume that what? Now let's say T1, that this T square 1 equal constant of this. Let's say this guy is constant. Then we have what? L1. Who doesn't understand what I'm trying to do? Who understand what I'm trying to do? What I'm trying to do is that I'm trying to create a relationship between period and the length. When you square these two guys, root L over G times root L over G, it will give you L over G. Are you getting what I'm saying? Yes, sir. Wait, I'll write this one first. Yes, there is something I want to bring out. Just write this first. Then we are now going to get okay, this is another problem again. 1991, JAMB 1991. Yes, JAMB 1991. I think I love that. Yes, JAMB 1991. That's very sweet. Are we okay with this? JAMB 1991. Are we okay with that? Are we okay with that? Hello, are we okay with that? Well, let's see. The boy can just estimation of a certain pendulum pairs and obtain in 10 seconds. Wow, I love this question. I love this particular problem. Very, very interesting. This is very sweet. Hello, I've seen a particular problem that I like. I love when I see problem like this. I'm always happy. When I see problems like this, I'm always happy. Hello, recall that we can also say that we can also say that that's relating, like just computing this for the other one. We can say this one is 4 pi square over G L2. Like making this one T1, making this one T2, making this one L1, making this one L2. So now class, if we equate T1 square, hello, if we equate T1 square equal T2 square. No, we are trying to derive an expression. If I relate this guy and this guy, I get that now. What I'm trying to say is that, hello, normally, if I divide all through, normally this guy will give me this L1. over what? This L2. If I'm to rearrange, are you getting that now? I'm going to get T1 square over T2 square equal L1 over what? L2. Look at it here. If you check the relationship, if T1 is equal to T2, if you divide all through, I get that now. This one will appear this over this. I get that now. This one will appear this over this. So if you rearrange, I get that now. From this expression, you are going to get this expression. So now, therefore, T1 over T2 is equal square root of what? L1 over what? L2. Yes. So now this is a formula that can be used should you have any question related to period and one length under simple pair.
Oh my God.
Why?
Oh my God, Sonny.
Why? The formula that you know.
Hello.
No.
So now here is the point. The period of a simple pendulum can be given by this relationship, as you can see on the board, that there is a relationship constant between the square root of the length of a simple pendulum bob, that's the thread, and the force of gravity that is acting upon it to the period. So that we can create a relationship between them where this is part of the constant, this is part of the constant, okay, and therefore this is equal to this. So that we can also equate the same value for this particular expression. So now for that reason, if we are to divide all through by the length, which is a particular constant, as we can see, we can have this particular expression. Now the essence of doing this is that with the length of a pendulum of different pendulum bulbs may be different. And that is why we are having this relationship. For example, if we are having a particular length of a single pendulum involving two cases, now we have a period and we also have lengths. Okay, now can we progress? Now, let's take this problem. Right. It's not yet time. It's not yet time. We have 9 more minutes to end the class. Right. What's the problem? Well, write down this problem. A simple pendulum is 0.64 meter. A simple pendulum is 0.64 meter. Has a period of 1.2 seconds. A simple pendulum. A simple pendulum. A simple pendulum. A simple pendulum, 0.64 meter, has a period of 1.2 seconds. Has a period of 1.2 seconds. 1.2 seconds. Are we there? Calculate the period Calculate the period. Calculate the period. Calculate the period of a similar pendulum. Of a similar pendulum. 0.36 meter long. 0.36 meter long. In the same location. Now, everybody, breathe down. Breathe in. Breathe in. Breathe out. Inhalation. Inhalation. Exhalation. Inhalation. Exhalation. Exhalation. You want to teach me? You want to teach me? What Mushi Medical School record? Hello. Well, let's continue. Hello. See how I'm going to solve this problem. The first thing I'm going to do is this. See what I'm going to do. Everybody look at the board, please. If you are tired, please tap your colleague not to sleep. See what I'm going to do. Hello. Hello. See what the first thing I'm going to do. See. Look at the board, everybody. But I know that T square is equal 4 pi square L over what? Over G. I know this. But butter G is equal 4 pi square L over what? T square. Now, I have two cases, but gravity is common. True or false?
Yes, sir.
I have two cases, but gravity is what?
Common.
So now my cases are equating this guy. 4 pi square L1 T1 square 4 pi square L2 over T2 square. Yeah. Can you see what I'm doing? Yes, sir. What is the first length? 0.6. What are they giving? What are they giving in the question? What are they giving in the question? T1 is what?
No.
L1.
0.64. The L2 0.36. 0.36.
T2.
Oh no.
Can you see?
Yeah.
So now what you are going to do is, you can see the way I equated them, because gravity is the same thing. So now from this point there, I can now fix my values. 4 pi square times, what's my L1?
0.64.
What's my T1?
That one is 1.2. I am to 0.6.
Abi, is it 0.6? Wait.
So 0.6.
I gave one at 0.64.
Yes,
I gave the other one at 0.36. So now this one I give me 4 pi square times what? 0.1 over what? This is what I'm looking for. So now I'll cancel these two guys out. Abi, then I'll now cross multiply. This one give me T2 square times 0.64 equal 0.36 times 1.2. Then this one will give me T2 square equal what? 0.36 times. So yeah, make operate. What do you get? What do you get? Ali,
0.81. Ali, are you mad?
Is that what you get?
Yes, 0.81.
0.81. So now let's find the square root. So conclusion, our T2 will now be equal.
0.81, that's 0.9.
0.9.
Second.
That's your final answer.
So now, 1 second.
Are you true?
Hold on, not now. We are online. Hello. I want to ask you this. Are we helping your life?
Yes, sir.
Are we helping your life?
Yes, sir. I'm right.
Who is telling me that 1 minute more? If I decide not to leave the class, what will you do?
Carry on.
Now, it is very clear that from the illustration you can see on the board that we actually related the two values that were given together based on the formula that we have derived earlier. So now what we are trying to do is we are trying to show you that there can be a communal. That means there can be a common relationship between the two values that is given. So now we are given the first initial length and we are given the first initial period, and we are able to relate these two together. So now, in conclusion, we have been able to show that we can have a simple pendulum that can have a similar length like the previous one, and that is exactly what you can see there. And that is why we are having the relationship this and this, and we were able to show that this is generally common for the two illustrations. That's why we are equating it. Now, what I actually mean is this: that even if we are to express from L1 and T1, and from L1, L2, and T2, we equate the both of them together. That is going to give us a common relationship. So gravity is common, so we can cancel gravity out, and therefore we can have these two illustrations. I think you are getting what I'm saying. So that's exactly what this. It's just like when you are saying gravity is equal gravity. Can you see that now? So you can actually equate them together. So,
Hello.
thank you. Thank you. God bless you.
Hello. 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 So we are done with this class, right? Okay, I'm holding screwdriver. Hello. Mr. Davila said something the other time. I want to be sure that you understand it. I remember in the first class, that is the one we had in the morning. He said, if you put an object at exact center of, if you swing it clockwise or anti-clockwise, what will happen to the object? It will not. So what rule is that, or what law is it? Again, if he has told you something about centripetal force, did he tell you anything about centrifugal force? Eh? It is what? Your, okay, so I'm very sure that in the next class, Mr. Damilare will explain everything you need to know about not even centrifugal force, about motion generally. He will summarize everything, give you concise and precise notes. Is that taking? Is that taking? A round of applause for Mr. Damilare once again. Now, hello, every one of you there, please move forward. Hello, everybody move forward. Hello. I will only count 3. After the count of 3, my students will keep quiet. After the count of 3, my students will keep quiet. 1, 2. After the count of 3, my students will keep quiet. If you are still talking after the count of 3, you will be the savior that will take away the sin of all these students. Now, first and foremost, I want to appreciate everyone for your cooperation. God bless you all. That is number 1. Number 2 of it is this. For those of you that are here in this physical class, if there is anything you do not understand, you can always go back to this video online to watch again. And if you are watching us online, you can always rewind this video over and over again to get every information you need to get. That is number 2. Number 3, it will be a crime on your part. If you are a member of this class, you are a member of this institution physically, it will be a crime not to have subscribed to this channel. And now, I am working on a video currently. Although I have taken my ignorance would make us to lose admission over and over again. Do you know that in 2023, if you scored up to 160, you could gain admission into university? And now, yes, to study what? Yes, that is, those are the things, those are the things that we are going to explain in the video that we are about to release. So I will implore every one of you that is here, please make sure you subscribe. And those of you that are online, make sure you subscribe. And you do not just subscribe. If there is any question you need to ask. Always comment the question. Is that taking? Like the video, all the videos, like all the videos, and share with all your friends. Share with all your friends. May God bless you as I end this live session. But as I'm ending this, nobody is permitted to leave. I have something important to discuss with you.